तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करने वाले हैं। इसमें हम लोगों को फ्रैक्शनल एरर निकालना है। फ्रैक्शनल एरर इन द वैल्यू ऑफ यंग्स मॉडुलस। To solve this problem, you need to know the Young's modulus formula, okay, which is stress divided by strain, which is equal to FL divided by AL. It is very important. If you don't know, remember or don't know this formula, then you will not be able to solve this problem. Determine Young's modulus of wire of radius. Radius of the wire is given. It is being measured. The radius is being measured with the scale of least count 0.001 centimeter. So when they give the least count, it is actually they are giving delta L or delta R. Whenever they are giving the least count, they are actually giving the absolute error in the measurement. Then they have given the length of that wire as well, 1 meter, and also the least count for the instrument or the scale. Then weight is also given 1 kg. Sorry, the mass has been given 1 kg, and the least count is 1 gram. Then it is hanged to the to get the elongation of 0.5 centimeter, and the scale of least count is also given for that one. So basically we have to calculate the fractional error in the Young's modulus. So we know this formula FL divided by AL. So FL is basically the force. So we have attached the mass of 1 kg to the wire, and because of gravity mg force will be applied. Capital L is the length of that wire before stretching. Area of the cross sectional area of the wire is pi r square, where r is the radius of that wire, and the small l is basically how much elongation has happened. Now to calculate the fractional error, this is the formula delta y by y. So once you know this formula, then you can easily convert it into this fractional error formula. You have to just write delta y by y is equal to, this gravity is basically a constant, it doesn't change, so we don't have to consider that. But mass we will have to consider because they have given this mass, and the error is also given in this mass. So what we do is delta m by m. So delta m is the absolute error in that mass and divided by the measured mass. Plus, since mass and this length is being multiplied in this formula, we have to use plus sign over here. Delta L by L. Again, delta L is the absolute error in that length of the wire, and capital L is the measured length. Then we are dividing here. So whenever we divide some quantity, basically we have to add that when calculating the error. That's why we have got plus sign. Then again pi is the constant, there is no error in the pi, so we can ignore that. Then there is this radius r square. So whenever there is something raised to the power, we have to take that power as a coefficient and then write it this way, delta r by r. Then plus L, small l is the elongation, so delta L by L. Delta L is the absolute error in the elongation. Now all these values they have given, okay, so we are just gonna put all these values over here. So delta M is 1 gram, okay, and mass was 1 kg, which is 1000 grams. So we have converted into grams. We can also do it in kg as well, but this was more easier for me. That's why I calculated in gram, because whenever we are dividing, it doesn't matter if we are considering it is in a gram or kilogram, because they cancel out each other. Then delta L divided by L. Delta L divided by L. So L is the 1 meter and delta L is 1 mm. Okay. So 1 meter is 1000 mm and here 1 mm. Then plus 2. They have also given what is delta R. Okay. What is the absolute error in the radius divided by actual radius, measured radius, which is 0.2. And then here they have given this delta L and L as well, elongation, error in elongation and measured value of the elongation. That's it. Once you put this value, just keep on calculating. You will get this 2 divided by 1000, 0.01, and this will be 0.01 divided by 5. Then 1 divided by 500 plus 0.05 divided by 5. So here we are multiplying by 5 to numerator and denominator so that we can add these numbers. and then we get 1 upon 500 plus 6 upon 500. Now we have to calculate this error in the percentage. That's why we have to multiply by 100. And once we do that, what we get is the final answer is 1.4%. So the error in the Young's modulus, percentage error in the Young's modulus will be 1.4%. Thanks for watching.